Hello, everyone. This is Miss Wright. I am recording today's lesson for Wednesday, March 25th and Thursday, March 26th. I'm recording this just because it's a kind of quick lesson, and I thought it would be easier if you could just watch it on your own time. So what we're doing today, let me share my desktop. Okay. What we are doing today is we are just reviewing solubility, and we're going to learn about an exception to our solubility rules, because like everything in chemistry, we have exceptions. So first of all, what is solubility? As just a refresher, solubility, as you can kind of see by that GIF on the left, for our purposes, we just think of it as the ability to dissolve or not dissolve. Is something going to dissolve? If it can dissolve, that would mean it's soluble. If it can't dissolve, we would say it is insoluble. Okay? So we learned last time that what determines whether or not something is soluble is this rule. Oh, for now I can just do full screen. Okay, this rule, like dissolves like. Polar things dissolve other polar things, and non-polar dissolves non-polar. Okay, that is our golden rule of solubility. So then you may be wondering, why is that the case? Well, if you remember last class and that awesome video we watched, it is because polar things, for our purposes, we can think of polar meaning it has charges, aka it has unequally distributed electrons. Okay, so if it has charges, it has unequally distributed electrons. That means that when you put two polar things together, their positives and their negatives, they are going to attract, and that attraction is what enables the dissolving. Okay, if you put something non-polar into a polar substance, non-polar, let's draw a little thing over here. Non-polar, it has no charges. I'm gonna just put a little 0, meaning no charge, okay? It has no charges, so the charges going on over here, the negatives and the positives, they're not going to be attracted in any way because it has no charge, so it's not going to dissolve. That is why non-polar can't dissolve in polar things. Talked about that before. All right, so what we are talking about today is, of course, it is chemistry. There are exceptions. So we know ionic compounds are made of ions, meaning they're always polar, they always have charges. However, there are exceptions to the rule of like dissolves like, because sometimes we've got ionic compounds that do not dissolve in water. Oof. Oh, one thing I forgot to mention. This is something you absolutely have to know. Water is polar. Okay. Oh, that's not how you spell. Water is polar. Can't forget that. So water is polar. However, how is it possible that we have polar ionic compounds that don't dissolve? Well, we got a chart of exceptions. The entire purpose of today is to get you to a point where you are able to read this chart. Okay. So this chart, whenever you are reading a chart, it is important that you start off with, where's my little pointer? It's important that you start off with reading the title. So here we have solubility of common ionic compounds in water. So this tells you right off the bat, this chart is only talking about solubility in water. Then we have, it says soluble compounds contain. And what we have here is a list of non-metals. So ionic compounds are always a metal and a non-metal. This chart is organized in terms of the non-metal. Okay, so we have a list of soluble non-metals here. And then if you look over, it says common exceptions. Okay, common exceptions. So that means that these are soluble in water except for what's listed over here. So if you look at the top half of this list, ooh, that's ugly. There are exceptions. It says none. No exceptions. That means this top little half is always soluble in water. So anytime you see a compound that contains CN or NO3 or ClO, that is always soluble in water, okay? But then we get down to the bottom and it says Br. Br is listed as soluble in water, except, and we can look at what are the exceptions. We have Ag, Pb, and Hg. Those are the exceptions. And of course, an exception to being soluble means that these, when paired with Br, would make it insoluble. So let's do a quick example. Let's say I've got KBr. Okay. KBr is an ionic compound. So right off the bat, we know it's ionic. We can assume, okay, it's going to be soluble. Well, let's check our chart to make sure it's not an exception. K is not listed as one of the exceptions. So KBr, then yes, that is soluble. But what if instead we had AgBr? Oh, it's so hard to write with this little marker. Okay. AgBr. We can look and we can see Br is soluble. And then in the exceptions, the first one listed is Ag. Ag is an exception to it being soluble, meaning nope, that would be insoluble in water. Okay, that's how this chart works. And moving on down to the bottom, it's important to note we have a switch. Okay, the switch is that now all of these listed here are normally insoluble. Okay, and then we have exceptions, meaning that anything listed under the exceptions is an exception to being insoluble, meaning that these would be soluble. Okay, so these would be soluble. So for example, this is one that we worked with earlier in the year, OH. Okay, OH or hydroxide is normally, no matter what it's with, is normally insoluble in water. It's listed under insoluble. Exceptions to that contain NH4, which is ammonium, the alkali metals, Ca, Sr, and Ba. So the alkali metals, that is the entire first column on the periodic table. So if you recall, an element in the first column on the periodic table is sodium. So NaOH would be an exception to it being insoluble, meaning that NaOH should be soluble in water. And if you recall our double precipitation lab, that is sodium hydroxide. That is the compound we used. We dissolved it in water, and it, in fact, is soluble in water. So it is an exception to being insoluble. Okay, so that is how this chart works. One important thing that you absolutely need to know, let me change colors so we can get it in a need to know color, okay, is this chart is about ionic compounds and exceptions to them being soluble in water. We know ionic compounds, ionic, made of ions. Ions are charged atoms. So we should think that they all should be soluble in water, which is polar. Because if it has charges, polar, water, polar, okay? So that being said, if there is something you do not see on this chart, you should assume, okay, it's a normal ionic compound, not an exception. Therefore, it is going to be soluble in water. Okay, this chart only has exceptions. So if there's an ionic compound, and again, I'll write it here, ionic compound means it has a metal and non-metal. If there's an ionic compound that is not on this chart, just go ahead and assume it is soluble in water. All right, so now we're gonna do some practice. clear all my drawings. Let's see, I want to quit out of this, exit. Okay. So this first one that we are looking at is AGBR3, and I believe I already did this example. Let me try and zoom this in a bit more if I can. It's so, okay. It's kind of cutting it off. Oh, no. Oh, gosh. Okay, let's leave it at that for now. Okay. So AGBR3, again, this is how we would approach the chart. Remember that the chart is organized by the non-metals. So anytime you see an ionic compound, the first part of it is the metal. The second part of it is the non-metal, meaning charts organized by non-metals. We're looking for bromine Br in our chart. So let's look. Br, 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 where do we see it, where do we see it? Okay, it's here. Remember, the chart's broken up into two sections, so we want to see, okay, what part of the chart is this in? This is the part that says soluble, okay? So we know that Br is normally soluble, so then let's see, is Ag one of the exceptions? Ag is an exception. Okay, it is an exception, and remember, an exception to being soluble, meaning it can dissolve, would mean that it is insoluble. That would be that answer. It's insoluble, can't dissolve in water. Alrighty, next one, K2O. Okay, I'll do this next example with y'all. So K2O, remember, chart is organized by the non-metal. Non-metal always comes second in our ionic compound. So here we're looking for just oxygen. Let's look at our chart. I see a whole bunch of oxygens, but these are in other things, right? We got a bunch of oxygens here, but it's part of this whole thing. We got one there, we got one here, but nowhere on this chart do we just have oxygen by itself, okay? Nowhere on this chart is just oxygen by itself, meaning that this is not on the chart, not on chart. Remember our rule, it's an ionic compound, it's not on our chart of exception, so we can just assume it is regular, so it will be soluble in water. Okay. So let's keep on keeping on. BaSO4. One thing I want to point out that someone had a question about earlier is that when we are looking on the chart, what we're looking for again is our non-metal, which is this whole thing, SO4. Ba is the metal, everything else is our non-metal. When you look at this chart, you can see kind of in the exponent spot, we have like here 2 minus, 3 minus, 2 minus, that's just the charge. Okay, so when we're looking for that, we don't really have to concern ourselves with that. That's just telling us the charge. What you're just looking for is the SO4. Okay, so go ahead, pause this video for a moment and try and figure this one out. Okay, did you pause it? All right, we're ready to answer this one. I'm confident that you got the right answer. All right, so SO4 is right here. Oh, why isn't it? Oh, I didn't click the draw button. SO4 is right here, okay? It is normally soluble. Common exceptions right here, Ba is an exception to being soluble. That means an exception to being soluble, this one would be insoluble. Oh, here's my cat. Okay, insoluble. Let's clear and move on to the next one. NaCl. Okay, go ahead and pause the video. Alrighty, folks, NaCl, okay? NaCl, if you look, Cl is on the chart right here. Na is not listed as an exception. So NaCl is normally soluble, Na is not an exception, so it's still gonna be soluble. Hopefully you didn't even have to use the chart for this one. You should just know NaCl, that's salt, sodium chloride, okay? Sodium chloride is salt. You should know salt dissolves in water. Next one, PbCl2. Pause the video. Okay, hopefully you paused, took time to figure it out. This one, PbCl2, is going to be insoluble. The reason for that is Pb is listed as an exception to Cl being soluble. So it's insoluble. MgF2. Pause the video. All right, MgF2. This one is soluble. Why? Not on the chart. Okay, not on the chart. So remember, we can assume that it is soluble. Oh, all right. And then finally, let's do this one, CaOH2. Please pause the video and take a moment. Oh my gosh, my neck. Oh my gosh, my neck just cracked so loudly. Okay, CaOH2. Let's take a look. CaOH2 would be soluble. Yay. The reason for that is OH is listed as being normally, hold on, let me move this. Oh, it's not letting me move this. Ca is listed, oh my gosh, this is a mess. Okay, here we go. Whew. OH is listed as being normally insoluble. Normally it will not dissolve in water. However, if you look at the exceptions, one of the common exceptions is Ca. So Ca is an exception to it being insoluble, which makes it soluble. Ta-da! That is how you use this chart. Let's see, do we want to do another example? All right, one more last example, SRS2. Sorry, not S2, just SRS. What do we think? Okay, pause the video. Pause, unpause. Okay. This one, hopefully you realize, is right below the OH. This one is soluble. Why? S is normally insoluble, and SR is listed right there as a common exception, meaning it would be soluble. Alrighty, folks, that is all for today. I hope that this video is helpful for you. On Google Classroom, there is the link to my folder with all of the online resources. You will see posted in the Lesson 2 folder something called Lesson 2 Exit Ticket. Okay, it is basically testing how well do you understand everything from last lesson and this lesson. Okay, so please go ahead, check that out. You do not have to turn it in for a grade, but I encourage you to just see what you still have questions with. Alrighty, that is all. Have an excellent day, everyone. How do I stop this recording?